Here's another piece of audiophile gear which I've had in for repair, and it's a CD player. Very nice, very solid aluminium, usual sort of monolithic, no fuss, concentrate on the sound CD player. Controls are a bit strange. There is a remote control for it, but yeah, basically nice bright blue display, nice solid case, very heavy, very weighty thing. CD mechanism. It's also got quite a few inputs, and the amount of transformers in this thing just for a CD player. Look at that amount of electronics, power. So this has got to be the least efficient CD player in the world. There's a CD mechanism there. You can see over the back of here we've got lots of inputs and outputs. It has got digital inputs and outputs, so you can have some electronics, Xilinx, digital audio chips, and then you've got a couple of valves. And the job of the valves, according to the Audiophiles, is to introduce distortion. It's obviously clearly very easy to make a flat response audio amplifier with these valves. As I said, these were intended for use in VHF TV tuners. They're just a lower noise, lower voltage version and lower gate and grid capacitance version of the ordinary standard 12AX7 valve. And what are they there for? Well, you know, they sound better. It sounds lovely, the valves. Oh, yes. And I got some sympathy with that, although with my ears, I may, it's a highly subjective thing, and I tend to be very practical about these things, and I can't really hear the difference, to be honest. You're taking the CD quality audio, making the most of it, and then deliberately distorting it to make it sound better. And the theory is, if you look, I'll show you some things from online, but the theory is that in this CD player, these valves take the final output analog signal, obviously not a digital one, and then pass it through a valve amplifier or a valve buffer stage, and the theory is that you get some nice sounding harmonious harmonics rather than discordant harmonics, which make things more interesting, more pleasurable to listen to. And they say, although I haven't seen it proved anywhere, and I'm sure it is, but I couldn't find it. I was just thinking, I was curious, so why have all this power for a CD player to distort your end signal? Fidelity, 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 I'll put some distortion in. So it's not like a tone control, which is varying the gain at certain frequencies and giving compensation for your speakers and your listening style, and perhaps the way the music is mixed and balance doesn't suit your ear, and you like to change it slightly to suit your own hearing and your own enjoyment. This is there to produce or introduce distortion. Now, we fight against distortion because we need to know that the thing is working, although the human ear can't really hear very small amounts of total harmonic distortion. But this is harmonious distortion, as I say, not discordant distortion. And the harmonious distortion we learned at university was the even harmonics. In particular, actually no, not the even harmonics, third harmonics. Yeah, third harmonic. So it sounds nice. You get higher octave, 2 octaves higher, extra signal introduced. As you know, any waveform can be expressed as a sum of sine waves. Any waveform you can think of, how irregular, you can express that as a sum of various sine waves. And this will be the third. So if you put a kilohertz in, we should see a 3 kilohertz distortion peak and once we filter that signal out again, we should see the fundamentals that make up that frequency displayed on the analyzer, which I've got just over there. Okay, so yeah. Anyway, so there's a feedback circuit in here which was bad on one side, so I fixed it. It's working all right. So now let's just hook it up to the analyzer we've got over here. Over here we've got the spectrum analyzer and an 8903B sweep analyzer, so that we can do the frequency response and the gain versus bandwidth on the sweep analyzer, and here we can actually feed a 1 kilohertz in from the Roder Schwarz precision generator. Have a look at the 1 kilohertz first, and then we'll feed it through the amplifier stage of the valve output stage, and then we'll see what harmonics are actually introduced to tell us whether this thing is working as a third harmonic distortion, deliberate distortion thing to make listening more pleasurable, or is it just valves for better than transistors? Who knows? Let's just put it on the analyzer and have a look and see what she does for us, shall we? Okay, so here, look, we've got a 1 kilohertz fundamental signal coming from our Roder Schwarz precision generator. Okay, 1 kilohertz at 1 volt, and we're meeting minus 0.13 dBs, minus 1.3 dB, should I say, which is a few millivolts down on 1 volt. So this is what's going into the stage, and if I just switch that off and look at what's coming out of the buffer, there's our signal coming out of the buffer. You can see we've got our fundamental at 4.4 dB, so we've got about 3 dBs, 4 dBs of gain on that stage. And then you can see here, look, that's the fundamental again, and then these are the harmonics we're interested in, and the audiophile like those harmonics quite a bit. And if I scoot along, you can see you've got 2 kilohertz at minus 35 dBs, and then you've got at 3 kilohertz we've got minus 45 dBs. So this is, as I say, a logarithmic scale. So this is probably a millivolt or two of versus 1 volt, a thousandth of that, and then this will be down another 6 dB, so that's going to be a quarter or an eighth of that as well. So very, very low amounts of harmonic being mixed in. I don't know if there's any higher order harmonics in there. Okay, so there you are, look, there's the fundamental first, second harmonic. There's some noise down here which is really down in the almost fractions of a millivolt, right on the noise floor. So this is noise, so there's a bit of noise coming out up here somewhere, up around the 20 kilohertz mark. So if I just up the fundamental to say 4 kilohertz, yeah, so 4 kilohertz is producing the same lovely sound, lovely valve sound. Let's try 8 kilohertz. There you go. So you got 8, 16, 24. So that's going to be above the audible range of the human anyway, or the Schumann. But that's what's happening. There's your lovely valve sound that you're paying for. Can you hear it? I think the ratio of these to these are very great ratios. So very tiny amounts of actually harmonic being added in. It's going to be drowned out by the fundamental and any other notes that are playing at the same time. So debatable whether you can hear it or not. The only thing I would say about our valve amplifiers, Valve got its reputation because when you were driving through an output transformer in a push-pull or a single-ended valve amplifier, you tended to get compression because when you started to overdrive at large volumes, you'd get a softening of the sound because it's kind of a compressor, because the flux in the transformer is becoming saturated, and there's some other factors as well. So the valve, instead of just cutting off and making a horrible discordant harmonics by a square wave, essentially just chopping the top of the signal off, which is what would happen when a transistor amplifier bottoms out, is with a valve output stage you'd get this compression, the rounding and smoothing of the sound. And I think that's where the reputation came from, and all the urban folklore is built up on this. But that's actually what you're getting, but these are very, very small in relation to that. I could rig it. I'll do it next time when I'm going to have another look at this, because I'm quite interested in this myself. We'll play the fundamental, and then we'll play the harmonics at those levels through a sound system, and you can see, or try and see, or try and hear if you can hear the difference. Try and see if you can hear the distance, or you know what I mean. Anyway, so that's what you get. But yeah, a CD player with valves in it. Who'd have thought it? It's not going to win any green awards, that's for sure, in terms of carbon footprint, if you listen to a lot of music on this thing, but, horses for courses. If you like it and you know there's valves inside. What's that little emblem there, look, you see? It's got a picture of an atom on the front as well. So that's atomic too.